Good afternoon, everyone. I am Ram Vignesh. Our project is blockchain based question paper security system. These are our team members. The main problem is that nowadays we hear more about leaking of question papers in universities, government exams, and even in foreign countries also these are all happening. Our project gives the solution to that problem. Using our project, these types of leakages can be avoided. Our project works like faculty uploads the question paper with the timestamp when the paper need to be released in our front end, which is HTML page, and encrypt the file using AES and RSA algorithm, which computes itself with the backend, and it shows the key. Then comes the decryption part, where need to enter the title of the paper, and using the connection with Ganachi, MetaMask, and smart contracts, it verifies the user and then allows to decrypt the paper. If the mentioned time is reached, then the download paper can be downloaded. If not, it will not allow the content to download. Question paper leaks are a major issues in universities and examination boards. Traditional storage methods like emails, PDFs, centralized servers are vulnerable to hacking and insider threats. Such breaches damage the credibility of institutions and affect students' futures. Blockchain provides a decentralized, tamper-proof, transparent way to secure exam papers. Our system ensures encrypted storage, time-locked access, and full traceability of question papers using blockchain. To prevent exam question paper leaks and unauthorized access, to enhance transparency and accountability in the examination process, to ensure time-locked release of papers using smart contracts, to provide tamper-proof and immutable storage of exam papers, to build trust among students, faculties, and administrators, to offer a decentralized solution with no single point of failure. These are the importance of our application. The related work is will be explained by Monish. Thank you.
Hello everyone, my name is Monesh. Let us see some of the works related to blockchain based question paper security system. The title of the first paper is Secured Question Paper Management System. The methodology used in this paper is it uses private blockchain with digital signatures, randomization, and OTACs to secure the question paper lifecycle. Let us see its features. The first feature is one-time access code. Provides unique time-sensitive access codes for distribution. Means the OTACs are like an OTP to open the question paper in the exam halls. Without OTACs, you cannot open the question paper. The next feature is digital signatures. It ensures the authenticity and origin of the question paper. Whenever the faculty uploads the question paper, he signs it with his digital signature to ensure its authenticity. The third feature is randomization. Shuffles questions to create unique sets for different exam centers so that even if the question is leaked in one exam center, it is infeasible to find an identical set of questions in another exam centers. Let us see its limitations. The first limitation is physical distribution risk. Prevents leak during printing and transit. This blockchain ensures the security of the question paper only until it is printed. Real-time coordination challenge ensures simultaneous OTAC distribution and validation across remote centers. Let us see the next paper titled A Proposed Model for Improving the Reliability of Online Exams Using Blockchain. The adopted methodology is blockchain Moodle integration, embeds a blockchain model within the Moodle learning management system. Let us see its features. The first feature is Moodle integration, extends an existing LMS for practical adoption. Instead of creating a brand new platform, this blockchain embeds on existing Moodle platform which is used by more number of schools. The next feature is transaction based records. Each answer stored as an immutable transaction for full auditability. Whenever student submits an answer, it is stored as a transaction in blockchain which cannot be altered. The third feature is wallet-based authentication. Student login and sign in with blockchain for decentralized identity verification. Instead of using username and password to authenticate a student, it uses his cryptocurrency wallet to identify him. Let us see its challenges. While the system enhances the reliability and security of exam results, its primary challenges are scalability and cost. Storing every answer on chain, especially on a public network, would incur significant transaction fees and could be slow, which may not be feasible for large scale exams. That is, storing each answer on blockchain could be costly. The title of the third paper is Blockchain Based Competitive Examination System in India. The methodology adopted here is comprehensive framework tailored for large-scale exams using a permissioned blockchain with IPFS for decentralized storage of encrypted question papers and answer scripts. Here the IPFS means interplanetary file system which stores file in a decentralized storage and returns its hash as a content identifier. Whenever the file is modified inside its storage, the CID is also modified, thus prevents tampering. Let us see its features. The first feature is context-specific design. Address trust and scalability in India's large-scale exams. End-to-end lifecycle management secures all phases of exam process. That is, from creation of the question paper till evaluation and declaration of results. It secures every phase of the exam process. RBAC via smart contracts enforces strict role permissions for students, examiners, and administrators. Here, RBAC means role based access control. That is, a student can only submit the answer while examiner can only evaluate the answer. Let us see its limitation. The limitation is the paper explicitly identifies several practical challenges, including scalability, user adoption, and navigating regulatory and legal issues related to data privacy and digital records. The title of the fourth paper is Permissioned Blockchain Based Remote Electronic Examination. The methodology adopted here is e-exam protocol uses a public permissioned blockchain with decentralized identity based verifiable credentials. Let us see its features. The first feature is verifiable credentials, privacy preserving identity management. Here, a student is authenticated without revealing his personal details, like using blind signatures. The next feature is normative via blind signatures, ensures unbiased grading. That is, whenever an examiner evaluates a paper, he doesn't know to which student that paper belongs, so it ensures unbiased grading. Comprehensive security guarantees question secrecy, mark privacy, and test or mark verifiability. Let us see its challenges. The primary challenge for this system is the implementation complexity. Setting up decentralized identity system with verifiable credentials and integrating it with a permission blockchain requires significant technical expertise and infrastructure. Let us see the next paper titled Enhancing Exam Security with Blockchain Technology. The methodology adopted here is DApp implementation, built with Ethereum, IPFS, and React frontend. Secure storage, encrypted question papers stored on IPFS with hashes and rules in Solidity smart contract. Let us see its features. Modern DApp architecture. It uses React, Ethers, and IPFS. Multi-factor authentication strengthens blockchain-based login security. Instead of directly login, the faculty or student has to provide a second layer of security like using OTPs. The next feature is formal security audits. The paper states the system underwent formal security audits and testing, demonstrating a commitment to robust and secure smart contract development. That is, this system hired professional code reviewers to identify the security flaws and vulnerabilities in the smart contracts. which demonstrates a commitment to robust and secure smart contract. Let us see its limitations. Like other systems using public blockchains, this model faces potential scalability issues, high computational overhead, and the risk of smart contract vulnerabilities that might be mitigated through rigorous auditing. Let us see the last paper titled Blockchain Based Secure Online Exam Approach for E-Learning. It uses AI and blockchain proctoring, secures online exam with AI, and stores proctoring logs, encrypted papers, and results on blockchain. Let us see its features. The first feature is AI powered proctoring. Integrates anti-cheating measures for remote exam environment. The AI constantly monitors the students through its webcam and microphone and detects for suspicious activities. Comprehensive security manages the security of both the exam data and the exam environment. IP-based login traffic analysis suggests additional network layer security measures. That is, the system constantly detects for any suspicious activity by student to hide his location or use any cheating tools. Let us see its limitation. The main challenge is the technical complexity and potential intrusiveness of AI proctoring system. Ensuring the accuracy of AI models and addressing student privacy concerns related to constant monitoring are significant hurdles. That is, during an exam, AI proctoring can feel like someone is spying on us, and AI can also make a mistake and flag a honest person as cheating, which creates ethical and legal concerns. That's it for the related works. Thank you.
Summary of gaps in literature study. Limited focus on education specific security. Most blockchain applications are designed to finance supply chain or intellectual property. Very few directly address examination security and question paper management. Lack of standardized framework. The existing or the research papers doesn't have a standard frameworks, uh, scalability and cost issues. It takes more amount of transaction costs and it limits the scalability. Time lock mechanism. The smart contracts which are widely used in the existing research purposes, they doesn't have the time lock mechanism. Integration with off-chain storage. We use IPFS to store locally in the desktop. User adoption and accessibility. It will be easily adaptable for the user. Real-time monitoring and alerts. Current works lacks a mechanism for real-time alerts in case of unauthorized attempts or system breaches. Problem statement: to design a blockchain-based question paper security system for secure, tamper-proof, and time-locked examination management system. Objectives: to analyze the challenges in existing examination systems regarding security, transparency, and paper leaks, to explore the potential of blockchain technology in providing immutable and tamper-proof storage of exam papers, to study the use of encryption, AES, and RSA algorithms for ensuring confidentiality and security management, to investigate the role of smart contracts in enabling access, control, and time-locked release of question papers, to develop a blockchain-based system for secure, transparent, and accountable management for exam question papers. The methodologies will be explained by Pratibha. Thank you.
Good evening. This is Pratibha. I'll be presenting you the methodologies implemented in the part of this project. Our aim is to design secure, tamper-proof, time-lock examination management system using blockchain technology. Existing methodologies. Let me begin with how the current question paper management system works in the institution. In the traditional system, the faculty prepares the question paper and send it to the secure printing press. After printing, the papers are sealed, enveloped, counted, and labeled according to the examining center session details. This sealed envelope are then transported to various exam centers and then stored in the local centers. On the day of examination, the head invigilator brings the envelope to the hall, breaks the seal, and distributes the paper. While this method appears procedure and secure, it has serious vulnerabilities. There is a risk of leakage and insect manipulation during the printing or transportation. No real time tracking or monitoring is available, and unauthorized access is difficult to trace or verify. And the entire system depends heavily on trust and physical security. The proposed methodologies. To address these issues, we proposed a blockchain based question paper system security that ensures confidentiality, transparency, and time lock access. Encryption layer. The process starts with when the faculty prepares an original question paper before uploading the document. It is encrypted using RSA and AES encryption. AES is the Advanced Encryption Standard. AES key itself is encrypted using RSA encryption provided in the additional layer of protection. This ensures two encryption components, the encryption system papers and encrypting AES key, blockchain based storage. The next, both encrypted files are uploaded to IPFS or interplanetary file system, which is decentralized cloud storage platform. Once it is uploaded, a digital fingerprint that represents the exact file version is copied. The CDI, along with the encrypted AES key and the timestamp, is stored in the Ethereum blockchain using the smart contraction. The smart contraction performs several important functions. It ensures the time lock release, it verifies the authorization of the users, it maintains audit logs for transparency, decryption, and authoritating access. On the day of examination, the invigilator uses MetaMask to authenticate their identification and send an authorized request for the access. Once the smart contraction verifies the request and release time, it automatically allows decryption. The AES key is first encrypted to RSA and then the question paper is decrypted using AES key. The decrypted paper is printed and distributed at the exam centers. Every access, decryption, transformation is recorded on the blockchain, providing complete traceability and the real-time accountability. Technologies used. The implementation of a system integrates several cutting-edge technologies: blockchain, Ethereum Hyperledger for decentralized and tamper-proof, smart contraction for access control and time lock release, IPFS for encryption off-chain storage, cryptological algorithm like AES for encryption, SHA for hashing and integrity, RSA encryption for AES key security, MetaMask for authentication, authorize and transforming signals, Node.js, Truffle, and Ganache for backend APIs and smart contraction deployment and testing, HTML and Python for front-end connection, cloud distributed service for hybrid storage, biometric or 2FA authentication for faculty and authorities examination, and the real-time alert for to track authorized access, attempt and generate.
Hello everyone, today I will walk you through the final part of our project presentation on blockchain based question paper security. Let's begin with the requirements. On the hardware side, we only need a simple setup, a dual core processor like Intel i3, 4 GB of RAM, and about 50 GB of free storage. A stable internet connection is essential, but no special graphics card is required unless we plan to accelerate cryptography tasks. Then we move on to software requirements. On the software side, the system uses the Ethereum blockchain for immutability with smart contracts written in Solidity to ensure access control and time locks. For storage, IPFS holds the encrypted question papers, while AES and RSA provide data and key security. MetaMask ensures security authentication, development, and testing rely on Node.js, Truffle, and Ganache. While Go IPFS and Remits ID make it easy to interact with IPFS nodes and smart contracts. And now let's talk about the status. At the national level, a prototype has already been developed for Indian universities. It securely stores exam papers and prevents leaks before exam time. Private universities have shown interest, and there is potential collaboration with government education boards. This effort aligns with India's digital education and blockchain initiatives, and the project is currently in the research and pilot testing stage. Then, at the international level, exam paper leaks are a global issue. They have been reported in countries like the US and the UK and across Africa and Asia. While blockchain is already used for issuing certificates and maintaining student records, extending it to question paper security is a fresh and promising application. This concept has gained attention in international research papers and conferences, creating opportunities for collaboration with tech companies and global universities. In the future, it could even support cross border online examination and set global standards for exam integrity. Moving to the conclusion, our blockchain based system ensures tamper proof, transparent, and decentralized exam management. By combining blockchain, smart contract cryptography, and IPFS, we secure exam papers with time locked access and full traceability. This eliminates leaks and insider threats while strengthening trust among students, faculty, and institutions. With its scalability, real time monitoring, and ease of use, the model presents a future ready solution for safeguarding academic integrity. Finally, let's acknowledge the references that guided our work. These are the references we have used in our project and we have developed this implementation. Thank you for listening.